You know, we use the word distance all the time, right? It feels so simple. It's just how far apart things are. But it turns out behind that one little word is this really beautiful piece of math that's secretly running everything from your phone's GPS to your favorite video games. So let's pull back the curtain and see how it actually works.
Okay, so let's start with a super basic question. Imagine you have a point A and a point B. What is the absolute, most direct, shortest way to get from one to the other? We're not talking roads, no obstacles, just a straight shot. How do you measure that? Well, the answer is what we call Euclidean distance, and it has a pretty cool secret.
And here's the secret right here. The key to finding the distance between any 2 points is to imagine a triangle that isn't actually there. Just keep that idea in your head, because we're going to build everything on top of it.
All right, first up, let's start in the easiest place you can possibly imagine, a single straight line. Think of it like a ruler or a number line from math class.
So, say you've got a point at position 3 and another one at position 8. The distance? Well, it's just 8 minus 3, which is 5. Super simple. And those absolute value bars, they just mean that distance is always positive, right? You can't have like -5 steps of distance.
Now here's where it gets really interesting. We can actually write that same exact formula a different way. And at first it might look a little more complicated, but trust me, this new form is the key that lets us jump from this simple little line into the real world.
So instead of using those absolute value bars, we can just square the difference, and then take the square root of that. Think about it. Squaring any number, whether it's positive or negative, makes it positive. And then the square root just brings it right back down to the original distance. The answer is the same, but this pattern, square, then sum, then root, that's what we're looking for.
So, where have you heard of a formula that involves squaring things, adding them up, and then taking a square root? If you're thinking of a certain ancient Greek guy who loved triangles, you are 100% on the right track.
That's right. This whole idea is so deeply tied to the Pythagorean theorem that sometimes they're basically called the same thing. And this is no coincidence. It's literally the foundation for how all of this works.
I bet you remember this one from school. A squared plus b squared equals c squared. It's the one rule that governs every single right-angled triangle in the universe. And as it turns out, it also governs the distance between any 2 points.
Okay, time to level up. Let's move off that simple number line and onto a flat plane, like a map or your computer screen. This is where the magic really starts to happen.
Hey, remember that invisible triangle I told you to keep in your head? Well, here it is. The straight line distance between 2 points is literally just the hypotenuse, that's side C, of a right triangle that's formed by how far apart they are horizontally and vertically.
And this formula really just lays it all out. It might look a little scary, but check it out. This first part, P1 minus Q1 squared, that's just the horizontal distance squared. That's our A squared. And the second part, P2 minus Q2 squared, that's just the vertical distance squared, or B squared. We add them up, take the square root, and we get the distance, C. It's just the Pythagorean theorem in disguise.
And here's the absolute game changer. Once you see this pattern, you can break free from flat surfaces entirely. The exact same logic works whether you're measuring distance in 3 dimensions, 4 dimensions, or even 1,000.
It just becomes a simple 4-step recipe. It's the same every time. For every dimension you've got, x, y, z, whatever, you find the difference, you square it, you add all those squares together, and then you take the square root of the whole thing. That's it. That is the universal formula.
And that is why this idea is so incredibly powerful. I mean, we can't really picture 1,000 dimensions in our heads, but a computer absolutely can. It can look at data, like all your movie preferences or the pixels in a photo, as points in some high-dimensional space, and use this exact same recipe to see how close they are to each other.
Now, this straight line, as the crow flies path, is the most common way to think about distance, for sure. But it's not always the most useful. Sometimes the path you have to take isn't a straight shot at all.
Right. Think about driving around a city like Manhattan. You can't just fly over buildings in a straight line, can you? No, you have to drive along the grid of streets. That's what we call Manhattan distance. You just add up how many blocks you go over and how many blocks you go up. It's just a different tool for a different kind of problem.
So at the end of the day, why does any of this invisible triangle stuff matter? Because it is hiding in plain sight, powering the tech we use every single day.
It's the logic your GPS uses to figure out the shortest route. It's how a video game engine knows that an arrow actually hit its target. And in a much more abstract way, it's how a streaming service can find a new song that is mathematically closest to your unique taste.
And that kind of leaves us with one last big thought. If we can use this math to find the distance between 2 points on a map, and a computer can use it to find the distance between 2 songs, what else can we measure? What's the distance between happiness and sadness, or between 2 totally different ideas? The math gives us this incredible tool, but what we decide to measure with it, well, that's up to us.